Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will talk about the components of the protection system. So fasten your belt and let's get started. The aim of the tutorial is to learn about the different components of the protection system and understand the function of each of those components and its job to clear the different types of electrical faults. So let's go ahead. Here we have some main components of the protection system, and the first component or element that the protection system consists of is the circuit breaker. And the circuit breaker job is to break the circuit or cut it in case of there is an existing fault in the circuit. So the circuit breaker is an element that cuts the circuit to be open by disconnecting the lines in case of there is a fault occurring in the circuit. Very good. Now the second element we have in the protection system is the relay, and the relay is a very important element in the protection system as it's responsible for sensing the faults by sensing some signals of the voltage level and the power system and the current level also, and then it analyzes those signals to know if those values are in the normal range or it's larger than the normal range, which means there is a fault. And after that, the relay sends some signals to the circuit breaker to break the circuit in case of there is a fault, or to continue the running operation of the circuit in case of there is no fault. So we can consider the relay to be the brain of the protection system, as it receives some signals and it analyzes them, and then it decides what will be the suitable action according to those signals. And also the third component of the power system is the current transformer, and the current transformer job is to transfer the electric current signal from the power lines to the relays. But this power signal has a very large value, so we cannot send it directly to the relay, as we need firstly to step it down to a very smaller value that the relay can read, and for that reason we use a current transformer which is responsible for transforming or step down the current signal from its original larger value to a smaller value that the relay can read. And by the same way we have the first component, which is the voltage transformer, as the voltage transformer is responsible for transferring the voltage signal from the power lines to the relay. But as usual, the voltage signal of the power lines is very large, so we cannot transfer it directly to the relay with its original larger value. So the job of the voltage transformer is to step the voltage signals down to a smaller value that the relay can read. So we can conclude that the voltage transformer sends the voltage signal to the relay, and the current transformer sends the current signal to the relay. Alright. Now let's see how those components are accumulated with each other in the power system to perform a protection system. Suppose we have this three-phase motor that we need to protect from any fault which may be caused in the power system. Here the first protection component that the motor will be attached to is the circuit breaker. So each of those three phases is connected to one circuit breaker which will cut the line of the power in case of there is a fault. Then the second component is the current transformer, where we have three current transformers, one for each phase, which transform the current signal from the power lines to the relay. And after that we have three voltage transformers, one for each phase, and they transform the voltage signal from the power line to the relays also. And finally we have the relay, which receives the voltage and the current signals from the power lines to the relay. And after that the relay sends some controlling signals to the circuit breaker to give it the order to close the circuit or open it in case of there is a fault. Very good. Now let's see how this protection system is working dynamically. Suppose there is no fault in the power system, so the passing current signal is the normal current value, which means that the current transformer will read the normal current value. So the current transformer will sense the normal current signal to the relay. And when the relay recognizes that the current signal that is received is the normal signal, the relay will recognize that all things are okay, hence it will send some controlling signals to the circuit breaker to close the circuit, as the circuit breaker will be closed now, which means the power will flow from the three-phase power supply to the three-phase motor. So that's for the normal condition. Now suppose a fault condition occurs in the circuit, which makes the current passing through the power lines to be a very larger value, so the passing current now is the fault current. Hence, the current transformer will send a fault signal to the relay. So once the relay reads the fault signal, it will send a controlling signal to the circuit breaker to open the circuit. Hence, the circuit breaker will do its job by opening the circuit, so the power will not pass from the three-phase supply to the three-phase motor at that condition. So this is the case at which we have a fault current related to the current transformer. But if we need to talk about the voltage transformer, we say that at the normal case, the voltage transformer reads the normal voltage value. Hence, it sends a normal signal to the relay, so the relay will recognize that all things are okay. Then the relay will send a controlling signal to the circuit breaker to continue the working operation of the circuit. So the circuit breaker will be closed at that case. But suppose another case at which we have an increase in the circuit breaker voltage, and this is due to a fault in the power system, so the voltage transformer now will read a fault voltage value, hence it will transmit a fault signal to the relay. Then the relay will recognize that there is a fault in the power system, so it will send a controlling signal to the circuit breaker to open the circuit to protect the motor from any increase in the incoming voltage signal. Alright. Now the last component we may have in the protection system is the communications channel. So the communications channel job is to receive data between the different devices that we need to protect. As in the network, there is not only one device to protect, but there are many devices to protect. So the communications channel now sends the data between the different devices to perform a handling operation between those different devices. And this data helps the relay to take the right decision to perform an action of cutting the circuit or not. Here we can see in that diagram, this is the communication channel and it's connected to the relay which protects the device. And it's connected to the other devices also, so it sends the data between the different devices for performing the coordination between the different devices, as it helps the relay to perform the right action. And we can note that both of the relay and the communications channel are supplied by DC power source, which are some batteries that exists in the power station. And this is because at the full condition, the power is getting off, but we need the relay and the communications channel to still working while the power is off. So we use the stored power in the batteries to feed those devices. More than great. So that's about this tutorial at which we explain the different components of the protection power system. Hope that's clear right now. Thank you for watching and see you next tutorials.